Hey guys, it's Coach Zane here, and in this video we're going to be talking about sensors and what exactly they do. So before we actually move over to the computer, I'm going to briefly explain the sensors we're going to use in this video. Okay, so we're going to cover 3 different types of sensors that we're going to use. So before we begin, let's define briefly what sensors actually mean. So sensors for the robot are exactly the same as our human sensors that we have in real life. So we're first going to discuss the touch sensor. So the touch sensor, like our hands and fingers, can feel touch. So there are 2 states that the touch sensor can calculate, and that's pressed and not pressed. Just like if I was to touch my hand, and I can say, okay, now I'm touching my hand, now I'm not touching my hand. So this is going to pick up some information that we're going to use to do other stuff. So the next one we're going to discuss is this light or color sensor here. So the reason why I've given it 2 names, light and color sensor, is because it can actually calculate 2 different types of things. The first one is color. So if we put it over a black colored object, it'll be able to discern that that is a black color. If we put it over red, green, blue, white, these are all colors that this can pick up. So I think there are 7 colors, including brown, as well as a few other colors that it can pick up. So that's going to be very useful over the EV3 map. As you can see, it's quite colorful. The other thing that this color sensor can pick up is light, which is why I'm going to refer to this mainly as a light sensor. So light is very different to color. In fact, just to briefly explain what light is, we're going to go a bit more in depth when we actually discuss the programming. Light is essentially, it'll send out a signal and that signal will return. Naturally, this sensor will pick up how much light will become reflected. So if you put it over a black object, black absorbs light, which means 0% should ideally be reflected back up. Which is why if it calculates 0% reflection, it'll know, okay, I'm over a black line. Now, if it's over a white, you'll know that white actually reflects 100% of light in ideal cases. So if it's over white, it'll pick up 100. It'll say, okay, now I'm over white. So this reflection value is going to be very important, and we'll discuss it more in detail. However, it's not that difficult to understand. All you need to remember is that black will absorb 100% of light, which means it will reflect 0% back to the EV3 color sensor or light sensor, which means it'll have a 0 to maybe even 20 to 30 value, and that will be black. And white reflects 100% of light. So if it's reading a very high value like 80 to 100, that's why it'll pick up 100. Now you might be asking, why did I say 0 to 30 and 80 to 100? And in reality, black and white values aren't really black or perfectly white, which is why we're going to have very small values like 20, 10, and 0 for black, and very high values like anything upwards of 65 is definitely going to be white. And we can only, with this reflected light intensity, we only cover black and white. So you don't need to worry about blue, green, all of those intensities. That's what we're going to use color for. And in other scenarios, we're going to be using black and white, which is reflected light intensity. The last sensor we're going to cover is this gyro sensor here. Now, gyro sensor is short for gyroscopic sensor, which is way too complicated and it confuses students. So we're just going to call this a gyro sensor. And a gyro sensor, in reality, what this calculates is the angle. Now, it doesn't calculate the angle inherently. What it does is it calculates how fast something is turning, and that's called angular velocity. It then integrates that over time to calculate the angle. However, you don't need to know any of that nonsense until you get up until year 10, year 11, year 12. You understand what integration is, and you'll be doing physics. So you can, for now, just understand that this sensor can calculate angle. And this is quite essential, right? Because if we want to do perfect 90-degree turns, this gyro sensor is going to allow us to do that. It's also going to allow us to keep us on the straight path, right? Because if we're going straight, it's going to be on one fixed angle. If it deviates from the angle, this gyro sensor will be able to pick up that error. So this is why this gyro sensor and this color sensor are going to be very important when it comes to future programs. This touch sensor, you can get creative with certain things you'll do with it, and that's why we've included it in this video. However, we've found that with FLL experience, this touch sensor isn't very essential. However, you have 4 ports on your EV3, and it's going to be, your choice to choose which sensor you go up to. Just to briefly discuss the EV3, we've covered motors. So you would know that motors go into letters. So we can see A, B, C, and D, and all of my motors, like this one and this one here, are plugged into these letters. So if you flip over to the other side, you can see there are sensors. And these sensors are labeled, if we can get that to focus, 1, 2, 3, and 4. So 1 is there, it's covered by a wire. 2 is there, 3, and 4. So something essential that you have to understand is that sensors can only go into numbers and ports for motors can only go into letters. And that's why in our programming, we're going to referring to port 1, port 2 as sensors, and port A, port B, or port B and port C as motors. So that's another important thing we need to understand before we begin. Now, another important thing you have to understand is that these sensors by themselves cannot do anything. They give us additional information from the robot. So after that initial information, then we're going to do something. And that's mainly we're going to be consisting of movement. Another thing you have to understand is that to use these sensors, you have to put them in the flow control tab. That's why we discussed the flow control in the previous video. And now we're going to use the flow control tab quite extensively in this video. So those are the sensors we're going to use. And now let's head over to the computer and actually see how to program these sensors into EV3 MicroPython. Okay, so this is my home screen. As you can see, I'm going to navigate down to EV3 Visual Studio Code. So I'll open that up. And as you can see, as always, we have this opening home screen right here. And now I'm just going to go down to the EV3 tab. And I've already got the user guide open. So it's right here. And now I just need to go back and create a new project. So for this project, what we're going to do is program our sensors. So I'm just going to call this using underscore sensors. And that should be fine. I'll just save it. And we should be ready to go. So as always, navigate to main.py. This is our programming environment. And the first 8 lines, don't touch them. As you can see, you can already see what's happening in this main.py, the first 8 lines. Because the first thing it does is import the EV3 brick. This is similar to the class name. So before we can actually use it, we have to import our components. And then you can see it imports the motor, it imports touch sensor, color sensor, infrared sensor. So all of these have already been imported. If this wasn't here, we'd have to import it ourselves, which isn't too much of an issue, but thankfully LEGO has already done it for us. Okay, so now, as you can see, it says create objects here. And I have no objects initialized. So in this video, we're going to be using sensors, but sensors by themselves don't do anything. Sensors give us information which we can then program to make our motors move. So I have to first initialize everything. And to do that, I'm going to first initialize my medium motor. So medium, as always, I'm going to call it something representative and not too long. So medium motor equals, and in the previous video, we discussed how to initialize our motor. So as you can see, it needs to be a capital M, followed by port.D. That's my medium motor. And now just to initialize my left motor, so left motor equals motor, and then I've got my left motor in port B, and then my right motor, right underscore motor equals motor port dot C. And now I also need to initialize my drive base function, or initially the robot. So to do that, just do robot. And if you remember from previous videos, you have to first put drive base, and luckily it comes up. And then you put in your left motor. So luckily my left motor is actually called left motor. So I'll just put that in, followed by right motor. This is just the object name of your left motor and your right motor. This is then followed by wheel diameter. So wheel diameter, oops, that's a spelling mistake, equals 55.5. You can have a space here if you want, it's just up to you. Preferably, it doesn't really matter because Python doesn't recognize spaces. So I'm just going to not put a space. And axle track. Axle, I've got a space there. Just for consistency's sake, I will delete that. Track. And my axle track is going to be 104. So if you forgot this initialization process, it's okay. As long as you have your documentation open. I got my drive base from here. And then to get all your motors, you'll just use this motor function class here. Okay, so this is going to initialize my medium motor, my left motor, my right motor, and my drive base functions. So this is what you're going to need to move forward and backwards. Now, we're actually going to learn in the next couple of minutes how to initialize each sensor. So the first sensor we're actually going to use is the touch sensor. So as mentioned in the previous video, the touch sensor measures touch. And the example we're going to use is if I touch the touch sensor, then I'm going to do something else. As you can imagine, sensors need to be used in correspondence with flow control. The reason for this is because every time you use a sensor, you're essentially asking a question to the robot. And you're saying, if this happens, then something else should happen, which is why we're going to be using loops and if/else statements very frequently within this video. So before we begin, we have to actually initialize our touch sensor, and I'll show you where to find that. So essentially you just have to go down, and instead of EV3 devices in the motor tab, just keep scrolling and you should see your color sensor here. We're going to do the touch sensor first. So to initialize our object for touch sensor, we have to call it something representative, followed by touch, sensor, and then the port it's in. And as always, the port is going to be the same. However, you're going to put port with capital P, dot, and then instead of A, B, C, D, we're going to do either S1, S2, S3. Just check whichever port you're in and make sure it's correct, otherwise it's going to return an error. Okay, so now let me initialize it. And a representative name. Now touch sensor, it seems a little bit long, so I'm just going to call it touch. That's fine. And then, as always, go back to your documentation, and what is the class name? It's touch sensor. So I'm going to write touch sensor. Luckily, it's already here. And then open up our brackets, and the port is going to be dot. For me, I've got my touch sensor into port 2, so S2. So where did I get this from? All this is I got my touch sensor. I gave an object name. For me, that was touch. For you, that can be anything you want. I then put this class in on the right hand side of the equation, followed by the port it was in using the capital P dot S4 or S1 or whatever port you're in. As always, make sure you have a dot to separate your port or your class name, followed by the description in the gray boxes. So that's where this comes from, my object name, my class name, and my port. Make sure it's like this and you have it in the right ports and you have all the case sensitive letters there. Okay, so that was how to initialize our touch sensor. Now let's make a program with it. So as you can see, there's this speaker.beep, which always seems to persistently be here. So let's delete that. And first we need to write while true. And I'll first write down the code and then I'll explain what the code does. So as always with our whiles, make sure you have a colon and then it should be indented. As you can see, that's where the indentation comes from. And now I'm going to write if touch dot pressed. I'm going to put brackets. I'm going to put equals. For now, you don't need to worry about what's happening. I'll explain it soon. And because it's an if statement, once you finish your if statement, you have to put a colon and you see another indentation. And then robot dot turn. And then we have 200 degrees. Okay, now let me explain what actually these 3 lines of code does. So the first one, while true, as we explained in the previous video, to ask a question to the robot, if this while true wasn't there, it's going to ask that question. If that question is false, it will then move on to the next line of code. So to actually make a sensor work, you need to have it running over a certain period of time, which is why we have this while true here, and then we have our if statements within it. So that's all the while true, the reason why it's there. Now we have our if statement, and as we explained in the previous video, the if statement simply gives the object a decision-making tendency. So if the touch sensor is pressed, then we're going to do a robot.turn. Now where did I get this function? That's one question you guys may have. Another question is, why is there a double equal sign? And why is there a true? So this whole line here may be a little bit confusing. However, let me explain where everything comes from. So let's go back to the documentation and let's go to the touch sensor tab. So there's actually only one command we can use with the touch sensor because it only does one thing. It only checks if the touch sensor is pressed. And that's where this comes from here. That's why I've written touch dot pressed with 2 open brackets, and that's going to check if the touch sensor is pressed. Now, if the touch sensor is pressed, it's going to return a Boolean expression called true with a capital T. If it's not pressed, it's going to return the same Boolean expression with false. Now, Boolean is essentially logic in the sense that it's either going to be true or false. You don't really need to worry about what Boolean logic actually is for now. It's very simple. It's simply if the touch sensor is pressed, it's going to return true. If the touch sensor is not pressed, it's going to return false. And that's why we want the touch sensor to be pressed and then we're going to do something. And if it's pressed, we're then going to write true. Why is there a double equal sign? Well, the reason is simple. If we have one equal sign here, it's going to return a syntax error because it's saying, why is the touch sensor equal to true? That doesn't make sense because that's the same thing as an initialization process. Because this is a question, you have to put a double equal sign. And what this is going to do is it's going to be a comparative task. It's going to ask, is the touch sensor actually pressed? This is the question of an equal sign. This is the statement of an equal sign. And they're 2 different things. The statement just says this is this. But the question or a double equal sign essentially says, is this this? So that can be a little bit of a mouthful and it's a little bit confusing. But once you actually make a mistake and you do this, then you'll realize, okay, I need to put a double equal sign. And the reason for it is because it's asking a question as opposed to just stating something is equal to something. So as you can see, if the touch sensor is pressed, it's going to return true. And then we're going to do a robot.turn. Now this line should be fairly straightforward. We covered it in our motors tab video, so you don't need to worry too much about what's going on here. All it's going to do is it's going to complete a turn. So let's see what the program actually looks like. So as you can see, it kept on turning. When I pressed it, then it stopped. So that's essentially all you need to know about the touch sensor. It's not very useful, and in fact you won't need to use it for FLL purposes because we found that the touch sensor isn't very accurate or very helpful. So now let's move on to something that is helpful, and that is the gyro sensor. Okay, so what does gyro sensor calculate? Gyro sensor essentially calculates the angular velocity and it integrates that over time to calculate angle. Now all of that gibberish I just said, if you don't understand it because you haven't done year 11 or 12 maths, that's okay. All you need to understand is that the gyro sensor calculates angle. And the reason it does this is because it's a gyroscopic sensor. And there are gyroscopic sensors in actually a lot of devices that you have. For example, your phone may contain a gyroscopic sensor to help the compass work. It doesn't necessarily have to, but it's a very common component in electronic devices, and it's going to be used for us to make our robot do straights and turns very accurately. So first, how do we actually initialize our gyro sensor? So I'm going to choose my object name, and I'm going to call it gyro. This can be anything you want. But gyro is fairly simple, it's easy to remember, and it's representative of what we're going to program. Now let's go back to the documentation and find the class for the gyro. So if we keep going down, it's the last one here. And as you can see, it's called a gyroscopic sensor. I'm just going to call it a gyro sensor for now. And the class actually is gyro followed by sensor and then the port. So it's very similar to the touch sensor in that it has the first letters that are case, capital, and then the port is going to be the same. So gyro, capital J, and as you can see, it's already here. So I'm just going to click enter. And I'm going to follow that by the port, and I've got my gyro sensor in port 1. So port.S1. And that's it. That's all you need to do to initialize your gyro sensor. Very simple. Okay, so what is the gyro sensor helpful for? Well, it's helpful to calculate angles. And one of the things that relate to angles is turn. For example, if this is my robot and I want to do a perfectly 90-degree turn, I'll flip it over just to make it a little bit easier to see. If that's my robot and I want to make a 90-degree turn, it's going to go from this position all the way to this position here. That has changed a 90-degree angle. So that's what the gyro sensor is going to calculate, and we'll be allowed to use the robot turn function in correspondence with the gyro function. And this is going to allow us to do perfect 90-degree turns. Now you might be asking, alright, how do I combine those two things, the gyro applications and the robot turn applications? And the answer is flow control. Flow control brings things together and it gives us more control over our blocks. So let me just write out the code first and then I'll explain what's going on. So now that we've initialized our gyro sensor, I can now put in our code. So I'm just going to do a simple 90-degree turn, and instead of using motor rotations of the wheels to calculate this turn, I'm actually going to put 90 degrees in as the gyro target angle. So my first line is going to be while gyro.angle. For now, I'll explain where this comes from later, is less than 90, and I'll explain what's happening soon. So as you can see, there's no indentation. That's because I forgot my colon. Always remember your colons. I can guarantee you it's going to be a mistake that you make, but once you make it a couple of times, then you can understand, alright, my colons are important. Okay, you can see indentation, which is good. That means we're doing something right. And now I'm going to use the robot.drive function, which is something that you may have seen before in the previous videos. I'm going to put 250 and 10. For now, I'm just going to keep writing my lines of code. Okay, and then I'm going to put left motor.brake, right motor.brake, and I've actually forgotten one line of code, if you remember. These are the 3 lines of code that make the robot come to a braking stop as opposed to a gradual stop, but the line of code that I've forgotten is the robot.stop function. So after I write this one out, the robot.stop function always comes before the left and the right, so robot.stop. Okay, so now I've just written 5 lines of code. Let me explain what it actually does. Okay, so the last 3 are quite simple, right? All it does is it'll do a turn, and then once that turn finishes, we want to come to a braking stop. So these last 3, it's as if they weren't there. They don't do too much, it just makes our turn more accurate. But I'll keep it there anyways because it's important. Alright, now let's work from the top. What is going on here? So while our gyro.angle is less than 90 degrees, we're going to do a turn. What does this mean, this first line here? Well, what does gyro.angle do? If we go back to the documentation, The gyro can actually calculate the speed or the angular velocity, which you don't need to worry about for now, but it will calculate the angle, which just gets the accumulated angle of the sensor. So for example, if the robot is here, when the program starts, it's going to see 0. Then as it starts turning, it's going to read 90 degrees, 180 degrees, 270, and then back to 360. And you can do whatever angle you want, which is why I've got, while the gyro angle is less than 90 degrees, I want to do a robot.drive function. Now let's just explain what robot.drive is, because you may have forgotten. Essentially, robot.drive, if we go back to the robotics and then all the way down, it's right here. Let's keep finding it. And it's right here. So this robot.drive function, you first specify a drive speed and then a turn rate. Now, if you want to go straight, that turn rate is going to be 0, right? Because you don't want to turn. However, if you want to turn, I've specified a turn rate of 10. What is this 10? This is 10 degrees per second. So essentially, it's going to do a turn as opposed to a straight, which is why I've put 10 there, and it's going to actually do a turn. Now, first I've got this 250 degrees, which is millimeters per second. This is just the speed. So all this drive function does here is it allows me to do a turn at a turn rate and a turn speed. So I've got these two parameters here. 250 degrees is the actual speed of the turn, whereas this 10 is like the steering power. And if this 10 was 5, it would do more of a curvy turn as opposed to a very fixed turn. So you don't need to worry about this too much. You can try it yourself. But this drive, robot.drive, it's not really essential for this video. Really, we want to focus on this gyro angle and this first line of code. So now that you know that this is basically just a turn, why do I have a while function here? Well, essentially, what we're going to be doing is while the gyro is less than 90 degrees, which is, it starts from 0, remember. So while it's less than 90 degrees, it's going to turn. It's going to keep turning and keep turning and keep turning. Once it hits that 90 degree mark and it goes above 90 degrees, then this while is going to be satisfied. And as we explained in the control tab loop video, all you need to do, once the while loop is satisfied, it then escapes the while loop and then moves on to the next 3 lines of code. And that is essentially how you create a simple 90 degree turn. So let me explain it once again from the top. While the gyro angle is less than 90 degrees, we're going to turn. Once that turn actually hits 90 degrees, this while loop will be satisfied, and then it will go to line 27. And line 27 to 29, all it is a stop and a braking stop of the robot as opposed to a gradual stop. So if these 3 lines of code weren't here, it'll still be a 90 degree turn, but there'll be some residual power into the motors, which is going to go over a little bit over 90 as opposed to like 91, 92 degrees. So let's put those 3 lines of code back. And this is going to be a simple gyro turn. So enough of me talking, let's see what this actually looks like. So quite simply, this was a simple gyro turn. And this was a lot more accurate than just robot.turn because we can specify an angle and it will hit that angle. Now you might be thinking, how do I actually check what angle the gyro actually made? And the solution is to write print. We haven't really talked about the print function before, but it's very simple. And then we're just going to put print gyro.angle. Alright, now what does this actually do? Well, the print function, it's slightly yellow. That's how you know it's a special operator. The print function will print something in the output tab here. So I haven't got my robot connected at the moment, but once you do, after the program completes, it's going to run how much angle it went. So this is good to check if it actually made a 90 degree turn. Now in reality, it's going to make like a 92 or 93 degree turn because there is still a little bit of inaccuracy in this gyro turn. In the future, we'll learn very specific advanced gyro turns to get that perfect 90 degree turn. So this print function, it actually doesn't change the positioning or anything of the robot. All it does is let us know the actual gyro angle and it prints it out onto the screen for us. So that's just what the print function does. It's actually quite important to check whether our program is doing what we told it to do. Okay, now what if you wanted to turn the other way? Well, quite simply, all you need to do is reverse the signs and the negatives. So as you can see, if you want to go the other way, the first thing you need to change is this negative 250. You need to put a negative sign in front. And instead of going one way, it's going to go the other way. Now, as you can imagine, if you go the other way, it's then going to record negative angles. So what you then need to do is change this to negative 90. And then you need to keep on going until it's greater than a negative angle. And that's essentially going to turn the other way. So they're essentially how you use the gyro, but just with specific to the gyro turns. And that's a very simple gyro turn. In the future, we'll learn 2 things with the gyro, and that is how to put a perfectly straight gyro straight, because as we explored in past videos, there are inaccuracies in just our motors. So we can actually use the gyro to keep the robot at a fixed angle using a gyro straight. We're also going to learn more advanced gyro turns to get that perfect 90 or 170 or whatever degree angle of turn you want to make. So that's the gyro in a nutshell. Let's now move on to the color sensor. I'm going to be referring to it as a light sensor, so because we're going to be using the light sensor to calculate the reflection of the robot. Okay, let's now move to the light sensor as we've completed the gyro sensor. So as we explained at the start of the video, the light sensor simply calculates the reflection of the whatever color that it's going to calculate how much light is actually reflected back in. And if we're hovering over black, that reflection percentage is going to be something low, somewhere between 10 to 20. It depends on the situation you're in, however, it's rarely going to go greater than 30. So that's for black. And for white, it's going to reflect a lot of light because white is a reflective substance. So what it's going to do is it's then going to reflect a lot of light, and it's going to go between 40 to 60. Sometimes it can even go as high as 80. It just depends how bright your white color actually is. So let's just delete all of this. And let me write down a line of code, and then I'll explain what it does. So before we can actually use the light sensor, we then need to create an object name. So I'm going to call it light equals, and let's go to the documentation and see how to initialize our light sensor. So go down to EV3 devices, and then I'm going to hit color sensor. And as you can see, the class for color sensor is this. Now, as we explored in past videos, this is actually the American spelling of color sensor, and you might be watching this in America and you might be thinking, all right, that's great, that's exactly what I know. However, in England and in Australia where I am, this is not how you spell color. However, you have to write it specifically as it is because this is an American made program. So just write color with an OR followed by sensor and then specify the port. So I'm going to do that now. So my object name is light. This can be whatever you want. And I'm going to put color, capital L, O-L-O-R. And then I'm going to put sensor. It's already here, so I'll hit enter and it should all come up. And now specify your port. For me, my port is in 4. So port dot, as always, S4. And that's the whole initialization process for your color sensor or your light sensor. Okay, so now let's actually make something with this light sensor. Now in future videos, we're going to make really advanced programs with our light sensor, but for now, let's do something simple. So what if there was a black line and we want to move forward until our light sensor sees a black line? How do we program that in? Well, quite simply, we're going to use a while loop first. So I'm going to type while, and then I'm going to type light dot reflection. And what is this light reflection? I've misspelled it. Let's get it right. Light reflection, yep. And then I'm going to go brackets. So what is this function here? Well, this function is essentially this reflection here, and this measures the reflection of the surface from the red light. So essentially it will release some signal, and how much is reflected back, it'll know. And as we explained, black is a low value and white is a high value. And it returns a percentage. So I'm going to go back and I'm going to say while the light reflection is greater than 15. So if the light reflection is greater than 50, we know we're not really on a black substance or a black color, because anything greater than 15 or upwards of 20 is either going to be, wood or white. So while it's less than 15, I'm just going to want to move forward. Now, as you can see, there was no indentation. If there's no automatic indentation, you know you've made a mistake, and that is because of the colon. So let's put a colon in, and then it should create an automatic indentation to signify the inside of the while loop. And then I'm going to do robot.drive. And as we explained in the past example, robot.drive is essentially just a straight, but you can specify a turn rate if you want to turn. For this example, I'm not going to want to turn. So I'm going to put -100 followed by a 0. So this is the speed I want to do in degrees per second, and then this is the steering power. And because I don't want to steer or turn, I'm going to make that 0. So all this program is going to do is it's going to go straight. It's going to go straight, and it's going to exit this while loop once the reflection has been less than 15, because this while loop goes forward, forward, forward. Once you hit a black line, which is less than 15, it's then going to stop. But is it going to come to a gradual stop? No, because we're now going to program the 3 lines of command that make it come to a breaking stop, which is robot.stop, left wheel, oops, I'll get that right, brackets, left wheel, left motor, sorry, dot brake, and right motor dot brake. Okay, let's see what this looks like, and then I'll explain what's going on. Okay, Okay, so as you can see, it went forward, it went forward, it went forward. Once it hit that black piece of tape, it then stopped. And that's exactly what we wanted to do. Because while the light reflection is greater than 15 or not on black, we're going to drive forward. Once it is on black, it's going to be less than 15 and the while loop is then going to be satisfied, which is then it's going to escape the while loop and then going to go stop and then brake both wheels. So this is essentially how to find a black line. Now obviously you need to know where the black line is, and luckily on FLO maps, it's not a secret where these black lines are. They're quite transparent. So you just need to go forward. Once you see the black line, then you're going to stop. Let's do one more activity using the white color value. So I'm going to write a few lines of code. This is probably going to be the most heavy example that we'll do today, but let me just write it out and then we'll explain what they do. And I'll briefly explain as we go. So the first line of code I'm going to do is while true. As we know, this while true function, all it does is continuously ask a question, which is why I've written it down. And then I'm going to do another while loop. So this is a while within a while, which is something we haven't discussed. But then I'm going to do light reflection. And we know what light reflection does. It just calculates the reflection from the surface the color sensor is over. So while light reflection is greater than 15, we know what this does as well. This checks if it's over a black line. If it's not, we're going to do robot.drive. So once again, so far this code looks exactly the same as last time. -100, 0. And then we're going to do our 3 lines of code. However, to make the robot stop. But to make the robot stop, you don't stop it here, because that is the outside of the while true loop. I'll explain why I'm going to make this indented. So robot.stop. It might be helpful to actually have this command already copy pasted because we're writing it so often. But if you keep writing it over and over again, you should get pretty fast. Break. As you can see, I'm not entirely fast yet, but I'm getting there. Break. So what this is going to do, while true, the robot will go forward. It will then, once it hits 15, it's going to escape this loop and then it's going to stop. So that's not too different to what we've done. So how is this program different with our next line of code? So I'm going to then do while, which is now another while loop. And I'm going to do a light reflection. And then I'm going to open up my brackets because that's what I need to calculate my reflection. Now I'm going to go less than 50. So according to my situations, I know I'm over light when I'm going to be over a 50 value here, which is why I've done while light reflection is less than 50. What do I want to do? I want to drive. Robot.drive. And as always, I'm going to put 100 here and then 0. I'll explain why this 100 is positive instead of negative soon, but this will become clear when you actually see the video. So try to figure that out for yourself. And now I'm going to put our 3 lines of code. Luckily they're already here, so I'm going to take this down and take this down. So before I actually explain exactly what this line of code does, I want to first show you the video, because you'll automatically sort of see what it's doing. So take a good look at this code, think about what this will do, and then move on to the video that actually shows what it does. So let's see what it looks like. Okay, so as you can see, that was quite complex, right? So it went forward. Once it hit the black line, it then started moving backwards, and it kept moving backwards until it saw the white tape. Then once it saw the white tape, it then moved forward and backwards, and this would have gone over and over again if I didn't stop it. So how did we do this in the programs? Let's explain it. So firstly, this while true, as I explained, that's just going to make the question go over and over again, and it's just going to completely keep hovering from white to black to white to black. All this does is make it go forever, because the while true is a forever loop. Okay, I then moved it forward, but I moved it forward until it saw a reflection of less than 15. Once a reflection of less than 15 was seen, this while loop is satisfied. The reason for this is because the while loop only escapes once this condition is false. So while the light reflection is greater than 15, it means it's not over black, which means it'll keep driving, and once it is over black, this will be satisfied because it's then false, and then it's just going to stop, which is what you saw. Once it actually hit the black line, it stopped for a period of time. But then it moves on to the next line of code, which is while the light reflection is less than 50, move backwards. So for me, my negative makes the robot go forward and my positive makes the robot go backwards. The reason for this is because the motors are actually inverted, they're a little bit flipped, but that just depends on the design of your robot. But either way, it doesn't really matter. All it does is instead of going forward, it's then going to go backwards until it sees a light reflection of greater than 50. Once it sees that, which is effectively the white tape, it's then going to escape this loop and then going to stop. But then that's not all it does, because remember, all of these two commands, which is go forward until it sees black, go back until it sees white, is in a forever loop, which means it's just going to keep oscillating and repeating this over and over again. Go forward until black, go back until you see white, forward, back, back, white. It's a bit of a mouthful, but essentially this program allows us to go forward and back between black and white. Now you might be thinking, alright, that's not that helpful in FLL purpose. How does that help me with our missions? Well, the good thing is, an FLL map has actually a black line, and then there are two white lines on the edge of this. So you can actually use the white line and the black line to do several things. So this video just explains how to find those white and black lines. But in future videos, we'll be explaining line following, which is essentially how do you follow a black line and go forward perfectly, and line squaring, which is if the line is straightwards like this, how do you make the robot perfectly perpendicular with this black line? So these are two things we're going to learn in the future. So hopefully you understand just in general how to use this light sensor and to find certain light values. Okay, so that wraps up this video. As I explained, there were 3 sensors we went over. It was quite a long video. However, it was quite intensive because it covered 3 sensors. The touch sensor, not very useful, and you'll most likely not have this on your robot. If you do, that's great. Just make sure it's effective for you and it's effective for your strategy. The second sensor we used was the gyro sensor, and we used an example to make it turn exactly 90 degrees. I highly recommend you guys to have a gyro sensor on your robot. It will make your programs very accurate, especially for Mindstorms, because it doesn't really have an internal gyro sensor, and the motor encoders are useful, but the gyro sensor seems to be more accurate than the motor encoders, at least in our experience. The third sensor was the light reflection sensor, and this video is being made in 2020, which is the replay season. And if you look at the replay map, you can basically traverse the whole map or go around the whole perimeter with just a light value. There's only one portion at the end of the map which doesn't have a black or white line. So that's pretty much the whole map is layered with black and white lines. So 3 color sensors are going to be very helpful for you. Even if you have 2, that'll still be helpful because you can just follow with 1. However, line squaring needs 2 sensors. So I highly recommend you choose your sensors strategically. Say what you want to do. You can also have a color sensor upwards, and you can have an attachment that when it sees a certain color of your attachment, it then runs a certain segment. That's a very useful thing to do. I've seen teams do it very successfully in the past, and it's going to make your technicianing process a lot easier. So you can use whatever sensors you want to use. Just make sure you have a strategic plan for it and you justify your decisions. That's the most important thing. You choose a sensor for a reason, and that reason is going to eventually help you at the competition and improve your robot. Okay, so that wraps up this video. Hopefully it was informative. Make sure you go over these examples, and if you don't really understand the whiles and if statements, then go back to the previous video and look at the control tab. And if you have any questions regarding that, ask me. Also, make sure you know where we got all of our initializations and our instructions for our gyro and color and touch sensors, which is in the documentation. So if you ever need to go to those, you can look at this video and then find them, or just go straight to the documentation and find it there. So hopefully you guys enjoyed it, and I'll see you guys in the next video.